Still got circles today, but we're talking about what we call the circumference of a circle. And then eventually what we're going to talk about is arc length of a circle. First up, circumference of a circle is all the way around the circle. You've probably heard of circumference before. So if I start right here and work my way all the way around the circle, then that would be what we call the circumference of the circle. A full revolution or a full path around the circle. There's actually two different formulas that we could use, and they're right here. So I'm going to put a star by those two, because depending on what we're given, I can use one formula versus the other. One uses the diameter, one uses the radius. We talked about radius and diameter in the last chapter, and so radius we know is half the circle. Diameter is all the way across going through the center. And they label them right here in that circle. So for the first one, if I have a radius, then the easier one to use would be 2 pi r, because we are given a radius of 9. So we would say c equals 2 times pi times 9. And there's really two different ways to write your answer here. One way to write your answer is what we say in terms of pi. And you're going to leave your answer like that in some cases, which means you're not going to multiply it. Okay, you're not going to take 18 times pi. We're just going to leave it in terms of pi. It's kind of like leaving your answer as a radical or changing it to a decimal. If they want the answer as a decimal, then we would go ahead and take 18 times pi. I would recommend using the pi button on your calculator. Most of you have a pi button on your calculator that you could use. I think on the TI calculators, it's like right above the division button, maybe. So you have to hit shift or second to get there. So you can look for that. Rather than using, I know you probably know that pi is 3.14, but that pi button takes pi out to multiple decimal places. Okay, so we should get about 56.55 if we round to the nearest hundredth. We might round to different places there. Every calculator is a little bit different, but we're going to be using that a lot throughout this chapter. On this next one, it says the radius of a circle with circumference of 26. So C equals 26. So we're going to do 26 equals 2 pi r. And we're going to work backwards to find out what my radius is going to be. So first of all, I would divide by 2. And remember, pi is not a variable. Pi is a number, okay? But we write it as a symbol. And so now I could divide by pi. So once again, you could use that pi button in your calculator. You could take 13, you could divide it by pi. And I think if I did it right, I'd get about 4.14. You're going to have to pay attention to whether they give me the diameter or the radius. This time they give me the diameter. So the better formula to use here would be C equals pi times 5. Remember, diameter is twice the radius. So the relationship these two have, if I double the radius, it gives me the diameter. So that's why both of these formulas work the same. But if I'm given the diameter, I don't need to double it. If I put that into my calculator, I think I get about 15.71. Okay, another thing that you're going to be given sometimes today, and I know this one doesn't say this, so I'm going to change this a little bit. I'm going to say, what happens if they tell me the circumference is 17 pi? They give me the circumference in terms of pi. You'll see that sometimes, where the answer is written in terms of pi. I want to find out what the diameter is here, so I'm going to use pi times d. The circumference is 17 pi, and the formula is pi times d. So if I want to solve for d or find out what d is, then I'm simply just going to divide by pi. And because we have a pi on both sides, those pi's knock each other out, and we're left with diameter of 17. If I had to find the radius, I would just divide by 2, and that would give me my radius. Okay, so really be careful about what they're asking for and how the answer or the numbers are written. Sometimes in pi, sometimes as an actual number. Okay, arc length. When we talk about circumference, we're talking about the distance all the way around the circle, but now we're going to talk about what if I only wanted to find part of the way? What if I didn't want to go all the way around the circle? What if I just wanted to find how long is it from A to B? We saw this a little bit in the last chapter, but we never did it where most of the time it was just given, and we used that as part of what we did. Oh. I do. No. You got no problem. Landon, you're supposed to be taking active place here with phone room. So they said they had that way.
Wait, where, the film room?
Film room, yep. Okay, so here's what I'm going to show you. This is the same formula that we just talked about, but we're only finding it for a portion of the circle. So what I need to know is how many degrees arc AB is right here that we talked about in the last chapter. So if this was like 50 degrees, I would be finding it for a 50-degree arc, but I want to find the actual length that corresponds with that. Okay? So we're going to find the measure of the arc over 360 times 2 pi r. This formula is the same formula that we just talked about. 2 times pi times radius. You could also use pi times d, but most of the time on these, the radius is what's going to be given to me, so we're going to stick with 2 pi r. So here we're going to do 60 over 360 times 2 times pi times 8. 8 is my radius. Okay, and we're just going to plug that right into our calculator. Okay, so let's multiply all that together. And we should get about 8.38. Okay. Most of the time, they're going to ask you to round to the nearest hundredth today, 2 decimal places. Big ideas, I think, is going to be the same way. You could round to a lot of different decimal places, but we're going to keep it hundredth most of the time. Okay, nothing really different about B, so I'm going to skip over to C because C is a little bit different. On C, we know the radius, but we don't know the number of degrees that we're dealing with here, okay? So in this one here, that's what we're trying to find out. We're trying to find out how many degrees is arc RS. So here's what we're going to do. We're going to write out a proportion. And when we think of the proportion, we're going to think of part over the whole, okay, for both sides of our proportion. So for the first one, 44 is the length of the arc that we want to know, okay, or that we actually know. But we want to find out how many degrees does that equate to. The circumference of the whole circle would be 2 times pi times 15.8. So this is the part that we know. This would be the full circle. So that's why I'm talking about part over whole. Whole circle, part of the circle. Okay, over here, we want an answer that's in degrees. Well, how many degrees are in the whole circle? 360. We already know that part, right? We want to find out how many degrees that matches up with. Okay, so here is the best way that I think to go about this. This is a proportion, right? We've seen proportions before. We've seen it a lot throughout the year, even in geometry. We saw it in Algebra 1. We're going to cross multiply here. So we're going to do 44 times 360. So punch that into your calculator. 44 times 360. And then we're going to divide by each one of these one at a time. So 44 times 360. And then we're going to divide by 2. Divide by pi, and then divide by 15.28. Do what? Okay. Cross multiply. So we're going to do this times this. Okay. Get that answer. Okay. Now leave that in your calculator, and then we're going to take that answer. We're going to divide it by 2. Okay. And then divide it by pi, and then divide by 15.28. My answer here should be a degree symbol. Okay, we're trying to find out how many degrees is arc RS. What do we get?
164.99.
Okay, 164.99. So I'm going to go ahead and write that as 165 degrees. So this arc from here to here is 165. And if you look at it, it should make sense, right? It's a little bit less than halfway. 180 would be halfway. RS is a little bit less than halfway. So my answer should make sense with what we know about circles. Okay? That's the best and quickest way to get that one. There's other ways to get there, but that's, I think, the easiest and quickest way to get there. On this one, it's talking about the difference between arc measure and arc length. Arc measure is the degree of an arc. So measure is always going to be in degrees. How many degrees is that arc? Okay, that would be the measure. Arc length is length. Length is always in distance. How far around are we going to go? When we talk about distance, we could label it in feet, inches, meters, centimeters, any unit of measure that we can think of, and you're going to see all different kinds of labels on those. But length's always got a label on it. Measure's always got a degree symbol on it. Okay, on this one here, arc PQ. Arc PQ is this arc right here. We're looking for the length of that, not how many degrees it is. That's what we did in the last chapter, okay? This is how many, or what is the length of it. We do need to know the degrees. What we just got done talking about in the last chapter was if the center is 75 degrees, the arc outside of it is also 75 degrees. So 75 over 360 times pi times okay, and 9, if you've got a length all the way across here, some people wonder, is 9 halfway? Is it all the way? If it's right in the middle, it's probably labeling the entire length here. If it was only on one side or the other, it's probably the half the distance. So this would be the diameter. So we could just go pi times 9. We don't have to double it because we already have the diameter. Okay, so on this one, we're using pi times d. We don't need to double it. So really pay attention to if it's the radius or the diameter. Okay, once again, we're going to be using our calculators a lot here because our answers are going to a lot of times be decimals. Here it's saying round the answer to the nearest hundred. So we got to know how to use our calculators to get to our answer. And when we're talking about yards, we're going to put a label on it as whatever symbol or whatever unit we're talking. Here we're talking yards, so about 5.89 yards. Okay, everybody good on calculator? Getting that punched in? Okay, this is the one, we're going to kind of do this one again. We're looking for the circumference, okay? So once again, here's where we're going to use that part over the whole again. Because what we don't know here is we don't know the radius. If I knew the radius, I could just plug it in and boom, I got my answer, right? We do not know the radius here. So here's what we're going to do. 61.26 is part of the circle, right? It's only a portion of the circle. The full circle, the full circumference is what we're trying to find. So 61.26 over x equals, okay, 61.26 is the length of this arc right here. We know the degree, the part of that is 270. The whole circle is 360. So when I know 3 out of the 4 parts, I'm going to put those 3 parts into the proportion, and we're going to find the 4th part. Okay? Same idea, a little bit different number that we're finding here. Here I'm looking for the whole circle. That's why I put part over whole here. I want to find the length of the whole circle, right? Just so you kind of make sense of what we're doing here. And once again, it's just a cross multiply. This one's a little bit easier to cross multiply and divide. So 61.26 times 360 and then divide by 270. And then we'll put meters on our answer. Okay. And it should be a little bit bigger than 61.26. Once again, just making sure your answer makes sense. 61.26 is part of a circle, so it should be a little bit longer than that. And it's like 3/4 of the circle, essentially. 270 over 360. Okay, on this one, find the radius, okay? I know how many degrees this arc is. Okay, this is the arc we're talking about. EF. 150 over 360 times 2 times pi times r. We don't know r. That's what we're trying to find. Equals the length of that arc, which would be 10.5. So we got to work backwards to find r. What could we do? Let's get rid of the fraction first, because I think that's the hardest part. What could I do to get rid of 150 over 360? What would be the quickest and easiest way? You could multiply by 360. And what we're going to end up doing is divide by 150. So what I could really do here is, when I have a fraction like this, I can multiply by its reciprocal. And that gets rid of the 150s, and that gets rid of the 360. So you're going to multiply by its reciprocal. It gets rid of the whole fraction at the same time. So you could do it in two separate steps. Like Cora said, you could multiply by 360 and then you could divide by 150, or you could put it all into one step, okay, which there you can use your fraction button. That's why I like using that as one step there. Okay, so put that in your calculator, 10.5 times 360 over 150. And then we're going to divide by 2, get that answer, and then we're going to divide by pi. So we're just going to break it down into steps. Because over here it's 2 times pi times r. So I'm going to divide by 2. You could divide by pi first if you wanted to. It doesn't really matter the order that you do it in, but you got to divide by both of them. I prefer not to do it at the same time, because then you got to make sure you use parentheses. So I would break it up into individual steps. If you used parentheses, you could do it all at once. So here, I think I got about 4.01. So my radius is about 4 for that circle. Okay, everybody good on that one? Calculator-wise? Everybody able to get there? Okay, example 3. We got this tire, okay? How many feet does the tire travel when it makes 15 revolutions? So if that tire goes around 15 times, how many feet would it actually travel? Okay? So what we want to do is we want to find one revolution. Okay, thank you. So if I wanted to find one revolution, okay, the first thing, as we look at this, 15 is all from the inside of the rim to the other side of the rim, okay? So if I wanted to split that in half, I could do that. I could do like 7.5 plus 5.5. But the easier way to do this is just find the diameter. So I'm going to do 15 plus 5.5 plus 5.5. I'm just going to find the diameter here. We don't really need the radius. I think the diameter is a little bit easier here. So the diameter would be 26. So to find one revolution, that would be the circumference. I'm going to take pi times diameter, which is 26. Okay, that gives me about 81.68. But that's one revolution. We want 15 revolutions. So I'm going to multiply that number by 15. Just leave that in your calculator. Multiply it by 15. Okay, now here's the other part that's a little bit tricky. The question says, how many feet does the tire travel? It doesn't travel 1,225 feet. It travels 1,225 inches. So how would I figure out how many feet it traveled? How many inches are there in a foot? 12. So I would take this number and divide it by 12. Okay. So about 102 feet. Okay. Big difference between those two answers because one's in inches and one's in feet. Okay, just because of time, this one's not too much different, it's just another conversion one. I want to do this track problem because you have one like this on your assignment today. You got to be kind of careful about the question that's being asked here. You got this track, and the two ends of the track. If I put the two ends of the track together, the two ends together make a full circle, right? The two sectors on either side. And then we also have in the middle here a rectangle. Okay, they're asking me how far around the track would I go if I take the inner path. The inner path is this red, and I know yours isn't color coded, but it's the inner part of that track. Okay, and so it would be 84.39 on either side. Okay, both sides of the rectangle. And then for the circumference, it's going to be pi times 36.8. Okay, now what I'm going to do here is there's two halves, right? So the two halves make one, okay? And so I'm going to do 36.8, but 36.8 is the radius, so then I got to double that to get the diameter. And then I'm going to add 84.39 plus 84.39. Because here's the path that I'm going to take. That red outline part right there. 84.39, 84.39, and then these two together make the circle. Okay. And I think what I got was about 400 meters. What do you think, Ryan? Does this sound right? Track? Yep. Okay. So one lap around the track should be about 400 meters. If you took the outer path, it would be a little bit more. There is a big ideas today, guys. I know it was quick and short and fast. Tomorrow I'll go over any questions if you have some questions.